Welcome again guys. The lecture 2 of electronics engineering KOE 038 or 048. The lecture 2, in lecture 2 I will discuss semiconductor diode basically. Semiconductor diode, in the topic of semiconductor diode we will discuss depletion layer, potential barrier and IV characteristics of p-n junction diode and ideal and practical diodes. First of all, p-n junction diode. What is p-n junction diode? So, sometime we discuss that when a p type and a n type semiconductor bring together, this is called p-n junction diode, but it is not correct, because the actual techniques to form p-n junction is that we should take one wafer, pure semiconductor wafer, like this pen is the pure semiconductor wafer. Then what will we do? From left side we will dope trivalent, like suppose we have doped 1 million trivalent, and from the left side we have doped, from right side we have doped 1 million pentavalent. This means automatically the half left part will form p type semiconductor and right half portion will form n type semiconductor, and the mid layer is known as p-n junction, like this. This is the p and n type semiconductor, we have formed p-n junction. Now, p-n junction will discuss under two headings: unbiased, unbiased means without battery, without external battery, and another topic, another heading is the biased diode. Biased means with battery, with an external voltage source. Okay guys. So, what will happen when the p-n junction will form like this? All of us know that it is p type and it is n type. At the left side these are the acceptor ions. It is very easy to understand, acceptor ion, and right side these are the donor ions, donor ions. This means here electrons are there, free electrons are there, and here holes are there. What will happen now? We should understand that at the left side there are deficiency of electrons, and at the right side of the junction of the mid layer there are extra electrons. What will happen? It is simple, that the electron will cross the junction and occupy the hole, but it is not simple that when electron will cross the junction and occupy the hole. Why? Because electrons are at the conduction band and holes are at the valence band. This means electrons are at the higher energy level and holes are at the lower energy level. So, first of all electron will cross the junction. This means the electron will move from the conduction band of the n type into the conduction band of the p type. Then it will occupy the holes, and during this process there will be some energy radiates. There will be a radiation of some energy. In case of diode, this radiation is in terms of heat, and in case of light emitting diode, this is in terms of light, or you can say photons. Then what will happen? Where? When one electron cross the junction and occupy the hole, then the positive donor ion and the negative acceptor ion, these ion becomes uncovered. Uncovered means this will behave like a dipole, like a dipole. This means n type become at the high potential and p type become at the low potential. This is like this, and this is a this will behave like a dipole. Okay guys. Now once again, this electron will also cross the junction and occupy the hole. Now these become two dipoles, and this electron will cross the junction and occupy the hole. Now there are three dipoles. This means the potential difference between the N-type semiconductor and P-type semiconductor increases. What will happen here, guys? You should attention here, that this positive potential will prevent the electron to cross the junction. Yani this positive potential will prevent the recombination process, because the electron cross the junction and occupy the hole. This phenomena is called recombination of electron hole pair, and this potential, these uncovered ions will prevent the recombination process. At an equilibrium condition, all electrons and holes near the junction will recombine, and now the prevention power is much sufficient that the further recombination process will not take place. At this equilibrium condition, there will be a region near the junction where no free electrons or holes are there, and this region is called space charge region or depletion layer. Since there are no free electrons or holes, that is why this will behave like an insulator, or you can say dielectric medium. Now, this potential difference which prevent the recombination process, and this potential barrier is called potential barrier. Why this is called potential barrier? Because this potential difference prevent the recombination process. Prevent, this means this potential barrier behave like a barrier, रुकावट का काम करता है. That is why this is called potential barrier, or some people call it barrier potential. So this is the physics of unbiased diode. And now the potential barrier, these are the example, the layer region near the junction where no free charge carriers or electrons or holes are present, only immobile ions are present, is called depletion layer. It is also known as space charge region. The depletion layer behave like a parallel plate capacitor. In the next topics or next lectures, I will discuss why this will behave like a parallel plate capacitor, how it will behave. The depletion layer is narrow for heavily doped diode and wider for less doped diode. Okay guys. Now I will discuss the potential barrier. In unbiased diode, the potential difference between N-type and P-type semiconductor which prevent the recombination process is called potential barrier. At room temperature, potential barrier of some typical semiconductors are germanium 0.3 volt, silicon 0.7 volt and gallium arsenide 1.2 volt. These are the potential barriers at room temperature. At room temperature, conditions applied here. At different temperature, the potential barrier will be changed. Okay guys. Now question arises, to start the recombination process, what will we should do? हमें क्या करना चाहिए कि हम दोबारा रिकम्बिनेशन प्रोसेस स्टार्ट कर लें इलेक्ट्रॉन और होल्स के बीच में, जो कि रुक चुका है, जो कि कंप्लीटली स्टॉप है. व्हाई? ड्यू टू द पोटेंशियल barrier. The simple answer is that when we will apply a voltage in opposite to the potential barrier, and when the applied external voltage will be equal to the potential barrier, or we can say when we will overcome the potential barrier, the recombination process will start and the depletion layer will vanish. The depletion layer will decreases to 0. This means suppose there are 4 electron hole pair which have recombined and it forms a depletion layer. This means when we will supply 4 electrons from this battery, actually what we have done, that we have connect a battery in opposite to the potential barrier. You can see here. We have connect this battery, negative plate of the battery with the N type and positive plate of the battery with the P type. Why? Because P type is at the low potential and N type is at the high potential. So, we have connect a battery in opposite to the potential barrier. Then what will happen? When exactly 4 electrons, here 4 electrons will be supplied to the N type, then what will happen? The 4 electrons will be repel here and these 4 electrons will also repel and N repulsion will be continue, and finally here the 4 electrons will be here. Then what will happen? What will happen here? 4 electrons will be here, and what will happen? The battery always conservation of charge low maintained by the battery, because since the 4 electrons has been released by this battery, this means the positive plate of the battery will attract 4 electrons from P type. 4 electrons will be attracted by the positive plate of the battery. Then what will happen? What will happen? That easily the 4 electrons will be extracted from the here, and there will be again 4 holes will be generated and 4 electrons will be collected by the battery. Negative plate donate 4 electrons and positive plate attracts 4 electron. By donating this 4 electron, the 4 electron will be here, and by attracting the 4 electron, there will be a generation of 4 empty place or 4 holes. And now you can see exactly by exchanging the 4 electron and 4 holes, the depletion layer vanishes. The depletion layer vanishes, cancelled out. Now, when the negative plate will donate the 5th electron, and that 5th electron will be circulate clockwise direction. When 6th electron, 7th electron, 8th electron, 9th electron, 10th electron continuously, when the battery will increase, the circulation of electron will increase like this, like this, like this, like this, and in the opposite of the electron, the current will flows in this direction, anti-clockwise direction. The direction of the current will be in the anti-clockwise direction, and the amount of the current will depends on the forward voltage, applied voltage, how much voltage we are supplying here. As we are increasing the voltage, the circulation of electron will increase and current will increase in the anti-clockwise direction. Okay guys, conduction starts at which voltage? The answer is exactly equal to the potential barrier. When we will apply the external voltage equal to the potential barrier, that is potential barrier will overcome, cancelled, depletion layer become 0, then conduction start. मान लो 4 इलेक्ट्रॉन होल पेयर के रिकम्बिनेशन से पोटेंशियल बैरियर बना था, तो हम अगर 4 इलेक्ट्रॉन दे दिया, इधर से 4 इलेक्ट्रॉन दे दिया, उधर से 4 इलेक्ट्रॉन ले लिया, तो डिप्लीशन लेयर खत्म हो जाएगा, कैंसिल हो जाएगा. देन व्हेन 5th इलेक्ट्रॉन विल बी सप्लाई, देन कंडक्शन विल बी start, simply like that. So this is called forward bias. In forward bias, the depletion layer decreases and forward current starts flow. Now what will happen? Now there are some terms in the forward bias. The first terms is called the knee voltage. What is knee voltage basically? The forward voltage across the diode at which it starts conduct rapidly is called forward, is called knee voltage or cut-in voltage. Knee voltage or cut-in voltage. For an example, suppose potential barrier of germanium diode is 0.3. So when we will apply 0.3 in forward bias, then it will start conduct rapidly, and for germanium diode 0.3 volt is the knee voltage. For silicon diode 0.7 voltage is the knee voltage. For gallium arsenide diode 1.2 volt is the knee voltage. This means the magnitude of the knee voltage is equal to the potential barrier. Now the reverse bias. What is reverse bias? In the same case, in unbiased diode, if we connect an external battery to support the potential barrier, हमने क्या किया? पोटेंशियल बैरियर को सपोर्ट करने के लिए एक बैटरी लगा दिया. लाइक दिस, द पॉजिटिव प्लेट ऑफ द बैटरी इज कनेक्टेड टू द एन टाइप एंड नेगेटिव प्लेट इज कनेक्टेड टू द N type. This means we support the barrier potential. If we support the potential barrier, the overall potential barrier will be increased. Overall hindrance, overall prevention power to increase. Suppose this is the silicon diode. There is a potential barrier 0.7 and we applied 5 volt. Then total barrier is 5.7 volt. And what will happen here? The positive plate of the battery will attract the electrons like this. Here electron will be collected by the positive plate here, and the negative plate of the battery will supply the electrons. So, what will happen here? Suppose 4 electrons is collected by the positive plate. Now, this region become deplete because these donor ion become uncovered, and now the same way here positive plate collects the 4 electrons, then negative plate will donate the 4 electrons, and these 4 acceptor ion will become uncovered. This means the depletion layer increases. No charge carrier will cross the junction. कोई भी चार्ज कैरियर जंक्शन को क्रॉस नहीं कर रहा है, कोई क्लोज लूप में कंडक्ट नहीं कर रहा है. सिर्फ क्या हो रहा है? चार्ज कैरियर्स गेट सेपरेटेड. चार्ज कैरियर गेट्स सेपरेटेड लाइक दिस कि 4 इलेक्ट्रॉन इधर से ले लिया और आप कह सकते हो 4 इलेक्ट्रॉन दे दिया या 4 होल्स ये ले लिया. तो क्या हुआ बालक कि चार्ज कैरियर सिर्फ सेपरेटेड हो गया, दूर हो गया, और कोई भी चार्ज कैरियर्स कोई क्लोज पाथ में कंडक्ट नहीं किया. इसका मतलब करंट फ्लो नहीं होगा. दिस मीन्स इन दिस कंडीशन द मेजॉरिटी चार्ज कैरियर्स विल नॉट कंडक्ट. Majority charge carrier will not conduct because the potential barrier increases. The potential barrier, the battery as well as the potential barrier of unbiased diode do not allow two majority charge carriers to conduct in the closed path. Only what happened? The majority charge carriers gets separated. That is depletion layer increases. Depletion layer increases. So, this is called the conduction of majority charge carriers not take place. But what will happen about the minority charge carriers? Yes, minority charge carrier can easily conduct, because we can see here that at p type minority charge carriers are electrons, at n type minority charge carriers are holes. Then this positive plate will repel the electrons, and this negative plate will also repel the electrons, and this potential barrier, unbiased potential barrier, will also support the minority charge carriers to conduct. This means minority charge carrier can easily conduct, and due to this a reverse current starts flow, and this reverse current is called I naught. This means reverse saturation current. Reverse saturation current is the maximum current before breakdown due to the conduction of thermally generated minority carriers, and this current is very small, vanishingly small. It is in order of nanoampere to microampere, nanoampere to microampere. This is called reverse saturation current. If anyone will ask you what is reverse saturation current, then you should answer that reverse saturation current is the current due to the conduction of thermally generated minority carriers in reverse bias, but it is before breakdown. After breakdown, the conduction will not take place due to the thermally generated minority carriers. The conduction will be happen in another way. I will discuss this phenomena, breakdown mechanism, in the topic of Zener diode, when I will discuss Zener diode. So, what will happen here in reverse bias? In simple that no conduction takes place due to the majority carrier, only conduction takes place due to the minority carriers. Since the number of minority carrier is very small, so that the current is also very small, and the order of this current is in order of nanoampere to microampere. I will give you the example in which semiconductor diode it is in order of nano, and it is in order of pico, and it is in order of micro. I will discuss it. Now, there are some definition. In reverse bias, the depletion layer increases as we increase the reverse voltage, the potential barrier increases, the conduction due to majority carrier does not take place because the barrier potential prevent the recombination process, applies force majority carrier in opposite direction. Opposite direction में force लगाता है majority carrier को, recombine होने नहीं देता. In reverse bias condition, the minority carriers can conduct because the reverse voltage barrier potential do not prevent the to conduct. The minority carriers conduct in reverse direction due to this a small current in reverse direction in order to nanoampere to microampere flows. Already I have discussed these terms. Now reverse saturation current. So, this is the example, the maximum reverse current before the breakdown. This is the reverse saturation current. Now already discussed. Breakdown voltage, yes, this topic breakdown separately I will discuss, but in reverse bias what will happen when we will increase the reverse voltage, the majority charge carrier will get separated and the depletion layer will also increases. At the point at the maximum point the breakdown will happen. This means the depletion layer widths will get collapsed and breakdown will start. There are two types of breakdown I will discuss in the next topic when I will discuss Zener diode, and there are two types, avalanche breakdown and Zener breakdown. I will discuss in the later topic. Now VI characteristics of p-n junction diode. This is the experimental setup of p-n junction diode. When we want to draw the VI characteristics of p-n junction diode, then we need two meters. One is the voltmeter which will be connected across the diode, and one is the ampere meter which will be in series with the diode. The ampere meter will measure the current, forward current, and the voltmeter will measure the voltage across the diode. Then what will we do? First of all, we take the reading of forward bias and we will take the reading of reverse bias. Here it is in the forward bias. Forward bias, if we will increase the applied voltage and in small intervals we will take the reading of this ampere meter and voltmeter and we will make a table. This is VD and this is ID. ID is in milliampere and it is in volts. We will take the reading and we will draw it, and in the same way we reverse the apply voltage and this will measure the reverse current, it will measure the reverse voltage and we will take the readings and we will draw finally. This is the characteristics. This is, here is the first quadrant, this is the forward characteristics, it is the reverse characteristics. In third quadrant there are three types of semiconductor diodes we have taken: germanium, silicon, gallium arsenide. Germanium, the knee voltage is 0.3, silicon 0.7, gallium arsenide 1.2 volt. This is the knee voltages, and we can see in the third quadrant in case of gallium arsenide, we can see gallium arsenide the reverse saturation current. This is the reverse saturation current. Reverse saturation current is in order of picoampere. In case of silicon it is 10 picoampere, you can say it is 10 picoampere and it is 1 microampere. Yes, this is germanium diode. Germanium diode has much higher saturation, reverse saturation current with respect to the silicon and gallium arsenide. So, this is the demerits of germanium diode I will discuss in coming lectures. Now, this is the diode current equation. Diode current equation is ID is equal to Is e raised to the power Qd by n Kt minus 1, where Vt is the Kt by Q, and we can write that ID is equal to I naught or Is. Is is the reverse saturation current, or I naught is also the reverse saturation current representation, Vd by eta Vt minus 1, where Vd is the voltage across the diode, eta is a constant. For germanium it is taken 1 and for silicon it is taken 2, and Vt is the thermal voltage and Vt is equal to Kt by Q, where K is the Boltzmann constant, T is the temperature in Kelvin, and E is the Q is the electronic charge. This is the diode current equation. This means diode current equation is the exponential equation. So, numericals may be asked in this question, diode current. Now, the ideal diode and practical diode. Ideal diode, there are three types of approximations. Ideal diode is under the first approximation. If ideal diode is in forward bias, this is like a short circuit and voltage drop across the diode is 0, and in forward bias voltage drop is 0, in reverse bias current is 0, and the graph of ideal diode is this. is this, this means Vd is equal to 0 and reverse current is equal to 0. This is called first approximation also. This is the ideal diode. Now, practical diode. This is the practical diode, the simplified practical diode and a practical diode. Well, here you can see, if the diode is practical, then diode is replaced by a battery 0.7 volt and Rb, this is the resistance, diode resistance, and this is the graph. This means the conduction starts at 0.7. Here Vd is equal to 0.7 plus IR, where I is the current and R is the resistance of the diode, and the graph of the practical diode is this. There is a simplified practical diode here. This means in simplified practical diode, resistance is ignored, and resistance is ignored. This means the Vd is equal to 0.7 volt. It starts conduct at 0.7 voltage, and this is for reverse bias and this is for forward bias. So, this is all about the ideal and practical diode, and this simplified practical diode will useful for solving of diode circuit, and it is very useful. Okay guys, so this is all about the working of p-n junction diode in forward bias, reverse bias, unbiased and ideal and practical diode. Okay guys, see you again.